Welcome to our 7-minute tutorial on DOCSIS 3.0. In this brief tutorial, we describe what DOCSIS is, and then focus on some of the new features present in the DOCSIS 3.0 standard. Specifically, we describe how the new standard achieves faster download and upload speeds in a cable network, and its support for the modular CMTS architecture. Throughout this tutorial, we highlight why cable companies want to deploy DOCSIS 3.0 equipment. DOCSIS is a set of data over cable standards originally developed by Cable Labs. The use of these standards has allowed the cable companies to mix and match vendor equipment in their networks, as well as create additional competition among the cable companies' equipment vendors. This has led to desired pricing pressure for this equipment. Lastly, the use of these standards have allowed the cable companies to share engineering costs. What's special about 3.0? 1.0 and 2.0 have already proved to be highly successful. With this new 3.0 standard, the cable companies are hoping to increase the bandwidth that they deliver to consumers. Many investors equate the DOCSIS 3.0 standard with its support for the modular CMTS architecture, but this is incorrect. Not only does DOCSIS 3.0 support the older integrated CMTS architecture as well as the new modular architecture, this standard also has new features for enhanced security, support for IPv6, and better diagnostics. We will spend the bulk of this tutorial's time discussing how these faster download and upload speeds are achieved. But before we get to that, let's briefly touch on some of the 3.0 standard's other features. Better security is provided through the support of AES, Advanced Encryption Services. Note, however, that these new security features are only available if both the CMTS and the cable modem near the subscriber both are DOCSIS 3.0 compliant. The new standard also supports the increased IP addressing space of IPv6 and has some features specifically dedicated to supporting business services. Although many investors focus on DOCSIS 3.0's increased downloading speeds, we believe it is the upstream bandwidth improvements that are driving the cable companies to deploy 3.0 equipment. In a cable system, the upstream direction is typically far more limited in its availability of bandwidth. Cable's hybrid fiber coax architecture deploys a branch and tree algorithm that inherently makes moving information more difficult in the upstream direction than in the downstream direction. This system was originally designed to carry massive amounts of video traffic towards the consumer and thereby only provides for tiny amounts of upstream bandwidth. Thus, cable MSOs have evolved these systems over time to increase this upstream bandwidth as they have added voice and internet access to their networks. DOCSIS 3.0 increases bandwidth speeds using several techniques. In the upstream direction, a portion of the bandwidth from the 42 MHz to the 85 MHz block has been reclaimed in order to provide additional bandwidth in the upstream direction. In order to make use of this bandwidth, however, cable companies must first move the analog channels that currently reside in this portion of the bandwidth or convert them over to an all-digital format. We will now describe how dynamic frequency allocation works in conjunction with channel bonding to increase upstream and downstream speeds in a DOCSIS 3.0 system. In older DOCSIS standards, frequencies and the resulting bandwidth from a CMTS are fixed for each subscriber. That means each home has a specific frequency and a specific amount of bandwidth on that frequency dedicated to it. In contrast, in a DOCSIS 3.0 system, frequencies are assigned as needed. This allows large amounts of bandwidth to be provided to a home for brief periods whenever the need arises. Dynamic frequency allocation also provides some sundry benefits to the cable MSO. Specifically, if there's an equipment failure in the RF shelf, the system can continue to function as normal with the remaining pieces of RF equipment taking up the slack. Likewise, if a particular consumer is injecting noise into the system, the frequencies allocated to that consumer can be reclaimed. Channel bonding refers to the use of multiple frequencies together to form a single fat pipe. In a DOCSIS 3.0 system, because of the inherent nature of the cable company's architecture, channel bonding, dynamic frequency allocation are both much easier to do in the downstream direction than in the upstream direction. The main advantages of channel bonding allow for much more increases in speed in both the upstream and the downstream direction. Other advantages are listed here. DOCSIS 3.0 also supports a modular CMTS architecture. For much more detailed information on this architecture, we recommend you view our tutorial on modular CMTS. We will briefly describe some of the highlights here. In a traditional CMTS architecture, the RF components, the routing, traffic shaping, and all other functionalities are fixed in one single shelf. In comparison, in a modular CMTS, each of these functionalities are typically provided in a separate shelf, thereby allowing separate amounts of them to be mixed and matched as needed. For example, if a cable MSO deploys an application that requires a large amount of RF capability and only a little bit of routing, a modular CMTS can be configured as shown. Conversely, that same CMTS can be configured quite differently if large amounts of routing are required, but only a small amount of RF capability is required. Thus, DOCSIS 3.0 achieves flexibility and increases in bandwidth through the techniques we have just described. It provides for enhanced security, lower latency, and reduced packet loss, and has some additional features for support of business services. The main drivers allowing the cable companies to deploy DOCSIS 3.0 equipment is the competitive pressure brought on by Verizon's Fios network architecture. That architecture, though not completely symmetric, has a much lower ratio of downstream to upstream capability than traditional cable company networks. The DOCSIS 3.0 standard goes a long way in helping to reduce this ratio for the cable companies, while not achieving complete symmetry in the upstream to downstream direction, does provide for significantly more upstream bandwidth than was previously available. This concludes our DOCSIS 3.0 tutorial.